Now we are going to see how to use CloudFormation to provision AWS resources. So far we have been seeing individual services like S3, EBS, EC2, auto-scaling, VPCs, RDS, Route 53. But how do I make an automation so that all of these services can be provisioned in a consistent manner, in a repeatable manner, and in an automated way? So this is where CloudFormation comes in to solve this problem typically, because let us say you have built up a resource in Mumbai region, and your manager comes up and says, "Hey, can you do the same thing in US region in West Coast?" So you have to start spending time and setting up all the resources once again, and it is going to take at least 4 to 5 hours to get all the resources configured properly. But in real world, you are not going to get 4 to 5 hours for setting up a resource which was already set up in your Mumbai region. You need to have faster deployment time, because if it is set once, why are we spending time on reconfiguring everything again? So if the same thing has to be done exactly the same way, there is a possibility that a human error will creep in invariably. Something might be missed out. Some configuration step must be left out. Something can go wrong. So CloudFormation tries to solve some of these problems. So today what we are going to see is what is CloudFormation, how to use it, and what are the common use cases or the building blocks of CloudFormation. And finally, I'm going to show you a simple template. I'm going to explain to you what is the template, what it is going to do, and finally we will run that template in the CloudFormation service and see what is the output and how much time it really takes to create an infrastructure from scratch. So when we are talking about the CloudFormation, I just now spoke about some of the problems. If you wanted a good architecture to be set up, a very simple one, not a very complicated web scale, a very simple 3-tier architecture that you want to set up in the AWS cloud, typically you will need almost all of the services mentioned here. You will need an EC2 instance, you will need a Route 53, and you will need some elastic IPs so that your IP address does not, your clients does not face any issues when they're trying to access them. You might also need load balancing if you have multiple servers. On the back end, you will need a database and VPC, security group, routing table, all of that at a network layer. And definitely you would want some monitoring for your servers also. And then you will also need some IAM roles either for administrative access or for your EC2 to interact with your S3 bucket or with your EBS volumes, or take some backup into an EBS volumes. So almost all of the services that you see on your screen will be required to set up a decent modern cloud architecture. So the number of people who can set it up every single time correctly, so all of the components work perfectly, is are very less, and error free and repeatable is even more lesser. People might have familiarity with them, people might have comfort with 1 or 2 services, but all of them every single time, that is not going to happen. Somebody might miss a security group, forget opening a port, or misconfigure RDS with some other security group, or do not open the routing table with the necessary routes for the internet. All of these things could happen if you do it all with your console. And you cannot repeat it, just as I said, if you are doing it in Mumbai, you cannot repeat it in US region, because all of those 10-20 steps that you need will have to be done exactly in the same way. And as I said, it will be taking at least 4 to 5 hours for each of the time if you want to set it up perfectly. So going through the console method, setting it up is not always the best option. It might save you time once, but if you're going to do it for a longer term, that is not the best option for you. Sometimes people say that, why can't I write a script? I have shown you scripts how to use a VPC script. But the problem with some of the bash scripts is, let us say an API call fails. Say for example, if you are given a wrong subnet series and an API call to the VPC fails, what happens to the remainder of my script? There are 10 steps in my script, the 4th step has failed. Should I go ahead and execute the remaining 6 of them or 5 of them, or should I roll back the first 3 that was completed successfully? What happens if I have to update my environment, only one value I have to change? For example, I want to change the routing table or the ports that I have to open. Do I open my entire script and find out where is the value and edit it? Or do I configure it with parameters and just change the parameters that I'm passing to my script and change it? So how do I keep track of all these updates? Do I need a version control system, or do I have to have a third-party system that controls my script so that I know who is updating it and what happens to an update happens? Should I automatically trigger an update to my configurations when an update to the script is made, or should I do it during a downtime, or should I do it in real time? So all of these questions happens when you're doing it through a script which is outside the control of AWS. So this might help in sometimes, but not always the case where script will be helpful. So Amazon says, why can't you use CloudFormation? Why don't you use CloudFormation? I have solved some of the problems that you are facing. For example, the timeout, how long you have to wait for a EBS volume to be created and optimized, how long you should wait for your RDS to come online. If an API call fails, should I roll back or should I not roll back? So all of this, or not, some of these problems have been solved by CloudFormation. And Amazon says if you want a predictable and repeatable and automated deployment for your resources, use CloudFormation. So because it's a template, it is the infrastructure as code, and how many ever times you run it, you are going to have the same identical copy. Whether you run it once, you have run it 10 times, you run it 20 times, and in the same environment, you are going to have identically same copies because you are going to parameterize certain inputs like a CIDR ranges, VPCs. So every time you create the template, you are going to get exactly the same copy of that environment. There is nothing going to be changing. And since the infrastructure is created as a code now, you can store this template into an S3 bucket. And since S3 has version control mechanism, you can have a control over what happens when the change happens to the template itself. So using S3 notifications, you can auto configure the template to update your infrastructure, or using the notification, you can send an email to your deployment team saying that there is a new template, go ahead and deploy it in the next available downtime. So your code is maintained separately and the deployment can be controlled automatically or using additional controls and checks. So in other words, you can modify and update resources in a very controlled and predictable manner for your infrastructure. So that is what, when you treat infrastructure as code happens, instead of treating them as servers, databases and storages. Because all the storage, databases, everything is just a piece of line of code in your template. Now we are going to call the script, instead of script, we are going to use the word templates going forward. And everything, whether you want to create a EC2 or a bucket or a RDS instance, everything is a piece of line of code in your template. So that is why always remember, when you're talking about CloudFormation, we are talking about infrastructure as a code itself. So this way, you can modify it anytime, and it is very easy to say, for example, I am running T2 micro. You just go to the template and then say that I want T2 X large or a medium, and then push the update to the CloudFormation. Automatically my instance will be updated. So you don't have to go to the console, choose the stop option and then start the server with a new instance type and all those things. So, and if particular person accidentally chooses something else instead of the correct one. So all those things are avoided when you're using CloudFormation as a code. And once again, as I said, the parameters are the configurations are configurable. That is a cyclic way of saying it. I mean, what I meant to say is, just like the instance type example that I gave you, you can change those configurations anytime, and you can modify them anytime and push them as an update. So it was just instance type. You can change your EBS volumes. You can improve the performance of your EBS volumes by changing the PI ops, or you can change your RDS also. Say, for example, SSD disk, magnetic to spinning disk or SSD disks. Likewise, you can take parameters through your templates, meaning if you want your customers, or let us, what happens is in real world, there will be a set of people who write a CloudFormation template who are very comfortable in writing the coding, and there are people who will be using the template itself. So if you're not sure who is going to use your template, you don't want to hard code your CIDRs for your VPC. They might want to use it in 10 series or 172 series or 9 series or some other series that they might be comfortable with. I mean the IP series. So you want to make it parameterized so that they can use the right IP series or the correct AMIs or the EBS volumes. So you can have a parameters, you take that input from your customers or users and then run your code. So this way your code becomes, or infrastructure becomes very flexible, and it is declarative. So the end user can decide and declare how they want to use it. And since the team that is creating templates is going to be sometimes separate, or they are going to be developers, they are going to aim for reusing the templates. This is a little bit of an advanced concept in CloudFormation itself. What it typically means is you don't want to redo the same thing, because if you're creating the same environment in multiple regions, you want to try and optimize the amount of code that is going to sit inside your template. So you want to see how I can reuse my stack. Let us take an example of a website here. And this website requires three resources, mainly an ELB, that is a load balancer, and auto scaling underneath EC2 will be there, and some AMIs and keys and everything will be there. And in the back end, I have an RDS database, that is a SQL database. So this is for my website one. So if I move forward, I have another website that needs to be developed, and the only change that I find is at the DynamoDB level. In the website 2 also, I have an ELB and auto scaling, but instead of using a SQL database, it is using a NoSQL database. So in this case, my network layer, that is ELB, and then my compute layer and auto scaling, both are common. So what I'm going to do is I will write a combined template which I will call it as ELB and auto scaling. So whenever somebody calls this template, I will provision them an ELB and auto scaling, and on top of that, I can create one more stack. That is, in other words, I will create two stacks. One is my network stack, and another one is a nested stack, which will refer to my this stack, and also create my database layer. So this is for the website one. Likewise, if I want a website 2, again I will create another stack website 2, which will refer to the previous stack and create a DynamoDB alone. This way, whenever I want to change, for example, an auto scaling or compute layer, I have decided I don't want Ubuntu Linux, I want to change Red Hat Linux. I will go ahead and update it only in this stack. I don't have to update it in two different stacks. If I have multiple stacks, I will have to do that there and another here. So that will have to be two places that I need to update and keep a track of. But if I am having nested stacks, all I have to do is I will just come to this place in auto scaling and then change the AMI that is given here, so that Red Hat is being used for all my websites. So this way my management time and configuration time is less, and less headaches and less things that will go wrong. So all of the people are going to be happy. Your service manager, your developer, your end users, everybody is going to be happy, because less number of things are going wrong, more time for your applications. So how do you plan your stack? So for example, your customer or your manager comes and says, build me a 3-tier architecture, and I want a database layer, I want two web servers, I want auto scaling, I want let us say load balancer, Route 53, and some users to be connected. How do I plan? Where do I start? In my opinion, and Amazon also agrees with this, is you start with your identity and access management, because you are going to know which users are going to connect to which other resources. So for example, if you want to build a compute or RDS, you might want to know what is the IAM role that is going to be connected to it. Remember when we saw RDS classes, there was a field which says what is the IAM role that is needed. So it is always better to know who is going to connect, what are the groups, what are the user roles and policies. And once you define that, then you go ahead and begin your network layer. So because when you need to know which VPCs, which subnets, which security groups, which ports, all those things are required. So once you build your network layer, then you go ahead and start your common services. In this, when I say common services, the alerting mechanisms, the security groups and subnets that we spoke about, and then you build the database layer now. Here, when I say backend services, that is a database. Usually in real world, databases contain some search functionality or payment functionality or reviews and recommendations, or in other words, database layer. Once your database layer is also done, then you go ahead and build your front-end services. This might be a load balancer in our case, or might be some Nginx server or a reverse proxy server, or just some simple web server or mobile front end also. That is also possible. So when in terms of environment wise, you create your dev, test, acceptance, and then production, however your company wants it. So this is the way that you approach logically the problem of building your stack. Start with your IAM roles, go with your network layer, then your database layer, then your application layer. And if you have front end, then build that finally. So that is the way you approach it. And there are multiple use cases are there for why you need to use CloudFormation, because as I keep saying, stack replication. If I want to do it the same thing multiple times, it is the easiest way to do without any errors or less errors, I would say. And infrastructure scaling out, you can push an update through an S3 notification or a Jenkins notification, and automatically my infrastructure is going to scale up or down depending upon what changes I have made to my code. Remember, I'm making changes to the code. I'm not touching my console. I'm not touching anything related to the resources. It is just a template. I'll go ahead and change it. We'll come back and see what is blue-green deployments in a short while. There is another better graphic to explain what is a blue-green deployment. It's more easier to understand that way. But remember that when we're talking about CloudFormation, we are going to think of resources in AWS as infrastructure as code. It is just a piece of line. Unless you execute it, nothing happens. And if you want to modify it, just modify the template and the code itself. That is how you are going to treat your infrastructure in CloudFormation. So these are the three main components that make up the CloudFormation service work. The first thing is the template. This is the place where you write your parameters and resources and configuration actions. When I say parameters, like what is the subnet group, what is the AMI, so what is my SSH key, and what resources, whether it is a EC2, whether it is an RDS, whether it is a VPC, what is a subnet, what are all those things. Finally, configuration actions. Say what should I send a notification to my team if my EC2 is successfully created. If there is a failure, whom should I notify? Or if there is a third party, that should I notify? So what are those configuration actions? So once you have written the template, and remember that when you're writing a template, it can be written in two formats. One is JSON and another one is YAML. So both are supported fully now by Amazon. JSON is a more JavaScript object notation, which uses a complex way, in my opinion. It uses a lot of brackets, commas, and you need to have the commas and brackets correctly. When it comes to YAML, it's one of the easiest format. Yet another markup language. Ansible also uses this format. If you are new to programming, I would say start with YAML, and if you're very comfortable with that, then move on to some other format like JSON, because the syntax is very much simple. Either you give a tab space or just two spaces and start writing the next syntax. So it's all dependent on the amount of space you start your sentence with. So it's very simple. I would recommend you to go ahead and check out in Google for more information on what is the YAML format. So let us say, assuming that your template is written, what you do is you feed it into the CloudFormation, and you can use the GUI or use the CLI format. And once you feed that, Amazon will process it, and it will either do a stack creation if it is the first time, but if it is the stack is already there, it will update it. And if there are any errors, it will detect those errors and initiate a rollback or trigger a notification to somebody. So once CloudFormation is created, this stack is created. That means that it is ready for use. And when it is ready for use, your CloudWatch events comes into picture, and event-driven notifications and event-driven processing starts. Probably you will trigger your Route 53 to start sending traffic to your production servers now, because your stack is completed. So these are the three main terms: template and CloudFormation service and the stack itself. So here is an example of a typical template sample syntax. It is not exact template itself. I'm just showing you the syntax and the format and the necessary items. Quite often people ask you what are the main things that needs to be in a template. So I'm just going to highlight it. If somebody asks you a question like what are the things that you want in a template, I would say the version is required, and a description for easily understanding it, and resources. There are other things that are there like parameters, mappings, conditions, and outputs. I would say they are all mandatory, but the only mandatory thing is I would say resources, as Amazon says, but I would prefer you to have the version also. The reason for that is today the APIs or how you interact with Amazon is consistent in CloudFormation. If tomorrow they change something, let us say instead of using ABC to call a EC2 service, and they will say that CDEF is the way that you need to call, you will be forced to update all your templates if you don't say that you are using this version. But instead, if you say that this is the version number I'm using, you don't have to worry about Amazon changing at the background, because they will still redirect you to the old version of the template. But down the line somewhere you will have to change your templates, but immediately you won't be impacted. So have your version number always when you're writing your templates. So the next thing is resources. As you can see on your screen, it is the meat of your template where you are going to configure what resources are needed in your template, whether it is RDS, EC2, auto scaling, subnets, VPCs, everything that you configure will be here. So the things needed for your resources will be picked up from the other fields. Before going to that, always write a description so that you know what you are writing in your template, whether it is a network template or it is a database template or a middleware template or your first template or company department. Write a user-friendly description. And parameters, we spoke about this. When you're creating a VPC, you need to know the CIDR range. So you need to get a set of parameters from your users. It is not mandatory. As you can see here, it is a required value is no. But if you are planning to get some input from your users, this is the best place to do it. And next is the mappings. This is quite an interesting field where you can enforce good behavior on your users of your template. Say, for example, from a corporate level, they have created a golden image with all the security packages and everything involved, and you want to make sure that people are using that golden image. So under mappings, you can do that. And later, I'll show you an example of how the mappings itself works. You can have multiple mappings. Say, for example, in Virginia, I have 5 availability zones. I want to ensure that people are using only 3 availability zones instead of all the 5. Then I can use mappings to ensure that they are not starting resources in other availability zones. And finally, conditions. This is a field where you are going to ask users certain inputs and make sure that input is going to match certain conditions, so that this way you can control what a resource is created. Say, for example, if a developer is coming and asking for a EC2, you will be provisioning them T series or M series. You don't want to provision a very big server for them. But if it is going to be a production, you will probably set up in R series or X series. So that way you can control what resources are being built. And the final thing that you want to have, or it is good to have, is outputs, because it is easy to pass this in as inputs to any nested stack. Say, for example, if you're building an EC2, you want to know what is the public IP address. If you're building an RDS, you want to know what is the end point of the RDS. So you can express them as outputs in your template. So this is how a template usually gets deployed. So left hand side is one stack. Let us assume this gray area is the gray box is one template that was written, and the template has created a stack here. And your manager says, okay, fantastic, everything is fine. I want to change my EC2 instance to a bigger instance now. So what you do is go ahead and modify this same template here, and then that modification has become like this template, and you run that from your console or your GUI, and that will go ahead and update the existing stack itself. So what this happens is, this is really quick, because you are going to update existing stack. I'm going to stop only my EC2. I'm just going to restart it with a bigger instance now. And because it is changing only one particular resource, it is really faster and cost efficient, because I'm not touching any of those other resources that might be in the template, like RDS or auto scaling and all those things. So it is simple, and I don't have to connect data migrated or anything, because my database is not changed at all. So this is what an in-place upgrade means, as you can see at the top. So in comparison to that, there is a new trend that is emerging, that is called as blue-green deployment. What it means is, once again, you have a template here, and then that template has been successfully processed by CloudFormation, and it has created a stack. And the same requirement, your manager comes and says, I want to change my EC2 instance. So what you do is, you take a copy of the template and you modify it, and you create a completely new template. And based on this new template, you go ahead and create another stack now. So both of them are identical, but one of them is serving production. So you test out your new stack, and you ask your developers, end users, and everything. So everything is okay, and everything is confirmed, everything is good. What you do is, you go to your Route 53 and start sending your traffic to your new server now. And your existing infrastructure is still available and still running. And if after sending your production traffic to your new stack, if you find that something is wrong, all you have to do is change your Route 53 back here. This way your downtime is absolutely minimal. And since the downtime is absolutely minimal, a lot of people choose this option, because losing downtime or facing customer feedback for downtime is more difficult for customers like Google or Facebook or Amazon. So they do something like blue-green deployments in the background so that people never notice any changes that is happening. And if any changes are also there, they will be routed back to the old environment, which can still serve traffic. And since you're not touching your old stack and you're creating a new stack, it is not exactly the cost efficient way. There is going to be more cost associated with it. But the advantage is absolutely minimal downtime when you're doing with this one. So sometimes people ask you what is blue-green deployment. This is what it means. So let us say that you have written a template and you are ready for deploying it. How do you check your templates are error-free? So Amazon gives you a few ways to do that. Amazon console can be used for validating your templates. I will show you a demo when you are talking about validation. And I mean, I will show you how to do a validation when I'm doing the demo. In other words, so parameter types, we'll see an example for each one of them in a short while. So when we are talking about syntax validations, Amazon will help you with the syntax validation, whether you have put the comma in the right place, whether you have put the bracket in the right place, whether you put a space in the right place, all those things. Amazon will verify those for you. But if you create a cyclic dependency, say for example, EC2 requires RDS and RDS will require some other services or some third-party services, and you can keep on building dependencies, and ultimately some other resource says I want EC to be built, EC2 to be built first, and Amazon will not know which service to start first. So the template will be stuck in that place and it will not get created. So do not create multiple dependencies. Have a logical flow to your template and then write out the template after you are sure that what you are doing. If you have multiple dependencies, your template is going to fail, or it is going to be very difficult to maintain or troubleshoot. So validate your templates for circular dependencies, and finally make the structure in a very logical, concise manner. Do not write unnecessary things, or just because you can have comments in your template, don't add comments or multi-line comments in your template. Be concise and precise when you're writing out your templates. So here are some examples about parameters and mappings. So in this case, I'm showing you an example of a parameter called environment, and I'm giving you three different values for environment, that is allowed values. If I write like this, my customers or end users of the template will see a drop down field, and from which they can choose any one of those options. Either it can be production or staging or development, and by default I'm saying development is going to be chosen. If my customer or user wants to change it, they can change any one of these three things. And likewise, you can see here there is a description field, and I'm going to force them to choose one of them to ensure that somebody is choosing some value, because a stack should not be created without any environment. So that is one way of choosing parameters. The another way is here is I'm building out an VPC here. It's another example for parameters, because I don't know where my user is going to run my template. So I don't know what are all the VPC IDs available under VPCs. I don't know how many subnets are available. So if I write like this, Amazon is going to automatically pick up the VPCs present in that region and list it out in a drop-down box. So you see here, it builds a list of all the subnets. Likewise, it is going to check all my security groups and list it here, and the different keys that are available in my account is going to be listed here. So this way, I don't have to know what is in your account, but I can build a template with the values that are in your account dynamically. So this way, parameters can also be dynamic. So this is an example of how it looks like on the screen. Here I'm just, as I said, the VPC is a drop-down box, as you can see here. And for subnets, you can choose it as a multiple subnets, because for RDS, if you're choosing RDS, you need to have two subnets, and also for auto scaling, it's preferable to have multiple subnets so that it is distributed across multiple availability zones. Likewise, you might want to use multiple security groups, so you can choose them as a multiple list. So this is an example of parameters. Let us move forward and see how a constraint looks like. Here I'm getting an IP address from my user, and I'm using a pattern matching to find out whether my IP address is of the right octet. Say it is 1.2.3.4, or it is 255.255.255, blah blah blah. So I'm just making sure people are not typing something like ABCD and trying to say this is an IP address. So this way I will ensure that I'm getting the right CIDR block for my VPC. Mappings here, as I said earlier, I'm ensuring good behavior here. I'm saying if you are going to launch in US East region, these are the three availability zones you will get. If you are in US West, these are the three availability zones. This way, I will ensure that my users are not launching resources in some other availability zone which I am not comfortable with managing. Because sometimes the compliance reasons will force you to use a particular regions and particular availability zones. Another example of mapping is subnets. So I'm forcing a user to use only these subnets in this environment. So if you're choosing production, this is the environment subnet IP addresses you are going to get. I accidentally rolled forward. So let us come back to mappings. So these are the subnets I'm going to get if I'm choosing production environment. So that is another way of enforcing good behavior for your users. And remember, we have seen CloudWatch when we were looking at the monitoring. So there was one section called the logs, and under logs, all the whether it is Lambda or whether it is RDS or CloudFormation, all of them will write logs. Even some of the S3 notification will also be written here if you configure it. I remember when we were talking about VPC flow logs, we came here, created a log group, and sent our accept and deny data here. So likewise, CloudFormation will also send its log files here, and you can go ahead and see whether it is running successfully or if there is a failure for my CloudFormation template. So typically in a production workflow, quite often this happens. There is a group of people who are doing dev work, and they are also writing application code and committing it into a version control system. And there are a group of people who are going to do ops works, and they are writing infrastructure as code here. So that is why you see it as infra commit. So now infrastructure is a code and they are committing into version control system. Sometimes maybe an S3 also, as simple as S3. And once the notification is sent to Jenkins or some other event management system will pick up the file and put it into an S3 bucket, because CloudFormation needs the template to be in S3. And once it is in the S3, it will take the URL of that object and send it to CloudFormation. So once it sends it to CloudFormation, CloudFormation will process it and will create a new environment. And let us say this is the live and this is the test environment. So once the test is completed and everything is fine, your Route 53 will start sending traffic to the test, and this will become the live server now. So this is a typical blue-green deployment works with the entire workflow for you. So now we have seen that what we are going to do is we are going to quickly build out a simple environment all from using a template. I'm going to build a VPC, and inside that VPC I'm going to build a couple of subnets, and I'm going to build one web server inside a web server security group, and I'm also build an RDS instance inside my RDS security group. So this is a simple environment we are going to build using a template. So what I have done is in the interest of time, I have already written the template and uploaded it, the code in my GitHub repository. You can also go ahead and try it out. I'm just putting the URL so that everybody can see there. So in case if you want to do it, you can contact me through the comment section and the URL will be available, or you can check out this URL that I've just pasted it here. So this is the one. And if you click on this one, it will take you to the template. It's loading. Here I have the template. It's taking time. Anyway, this is the page it will load. If you click on draw, it will load something like this. So this is how the template looks. I'm going to copy this and paste it into my notepad file, and then let us say if I can choose YAML format so that the syntax highlighting works. Yep, there we go. So you can see here the first line of my template is the version, and second one is my description, and under that I have something called metadata. This is for grouping my parameters. So I have grouped something called parameter groups, and under that I put all my network configurations, CIDR block, public availability zone, private availability zone, public CIDR, private availability zone, and also my private subnets. So there is a second group which is called as an EC2 instance configuration, and from users I'm going to collect my instance name, type, and environment. Likewise, I have another group for RDS, collecting them the instance ID, database name, database password, blah blah blah. So I'm going to start my parameter section actually here. And you see here, this is the syntax of an YAML file. Typically, it is two spaces. As you can see here, I have highlighted the two spaces. So first line starts at the beginning, and the next line, which is inside parameters, is a CIDR block, which is given as two spaces. And under CIDR block, I'm having multiple values, and they are all having about 4 spaces. So if I'm creating another parameter, I'm just coming back to another line which says about 2 spaces. Here in this case, public availability zone. So I'm collecting the CIDR block, I'm collecting my public availability zone, and it is automatically picked up because I don't know where my user is going to run this template. So I'm automatically picking up from my account what is the availability zones in this region, and getting the public CIDR, and then again private availability zone and private CIDR. In other words, what is the IP address? In this case, I have given a default value if people are not sure what to type in there. So this will give them a nice prompt of what should be there. In case that is not suffice, there is another description field also where you can have a more descriptive parameter for them. Let us say this one should be private subnet, and the next parameter that I'm collecting is instance name, and I'm saying this is just a string and people can type whatever they want. And then next I'm saying instance type. Here you see here the default value as of now is T2 micro. So what I'm going to do is, let me just go ahead and add something like T2 nano, and I'm just going to add C4 X large. So these are all 3 drop-down servers or options that I will get. And you see here by default it says T2 micro. So that is the instance name. And for key name, you can see here automatically it goes to my account and picks up the key name. And default I have given on key name. If this key is not available, it is not going to be pre-populated. Say for example, I'm going to run it in Mumbai region. This key is not available. It will not populate it in the default option or in the drop-down list. And again in the environment, I'm giving them 3 choices or 4 choices. And public IP, do I want a public IP or not for my instance? It is a true or false value, and I'm default, I'm choosing true. So likewise, I'm collecting a lot of parameters for RDS also. So all the way up to here, I'm collecting input parameters. You see here already we are at line number 124 of my template. So mappings, here I'm saying if you are going to launch my instance on US East, this is going to be your AMI. If you are going to launch it in AP South, that is Mumbai region, I'm going to give you a 64-bit AMI, and this is what the AMI ID is. This way you can create a golden image and put it here, and automatically any instance created on this template will automatically pick up this AMI ID. So finally, I'm coming to the mandatory field of my template, that is resources. So under resources, I'm creating my VPC. So as you all know, for a VPC, I will need internet gateway to get internet access, and a gateway attaching the gateway for internet access, setting up my route tables, and public route is getting created here, and public subnet is getting created here. So these are all exactly the same steps that you do it on the console in the same sequential order I have mentioned here. I'm creating public subnet and I'm creating private subnet, and see that automatically tags are also getting created. So the tag will have a name, and the value of the tag will be the stack name plus the availability zone, something like my stack hyphen AP South 1A, something like that. It will be automatically created. So creating a private subnet, and then there is my tags there, and then you see here all the values are referenced. Whatever you choose in the parameter section, automatically the value for the private availability zone will be picked up from my parameter section and updated here, and my CIDR which was created during the parameter section will be updated here. This all the next few steps are up to this is all about subnet association, I mean routing table and subnet association with the routing table. So you see here it is referencing to the routing table and referencing to the private subnet. If you remember how to set up a VPC, you will be able to understand this flow up to this point. So finally, I'm creating my security groups also. It's a web security group, and I'm allowing port 80 here, and I'm allowing internet access also for port 22 to troubleshoot if something goes wrong. Finally, I'm creating a DB security group, and I'm saying that create the DB security group inside my VPC, that is the VPC that we created earlier. I'm referencing to that resource. If you see here, I'm not creating any inbound or outbound rules here because I'm going to write them separately below this as something like this. DB inbound rule is this port, and my input is going to be only from my web security group. And if you remember, we just now created a web security group somewhere here. So I'm going to say allow only my web security group to contact my DB security group. This way I'm not opening it to my internet access. And I'm also creating a DB subnet group. If you remember, a DB subnet group is different from the VPC subnet, because if you want it to be private, you're going to list all the subnets here. Although I'm doing both of them here, it will because you need to have multiple subnets listed, and I mentioned both of them just to comply with the requirement. In production, it will be always private subnets here. So finally, the other resource that I'm creating is a web server. And once again, the web server will need a key. It will need an image ID. It will need an instance type. It will need which subnets, what is the security group, what is the user data field. And once you give all these details, this is going to build me a web server. And the next few configuration steps is for my database server. And it is going to take my database name, engine, master name, master password, and all those values. And finally, up to this point, I'm just creating my resources, just two resources, VPCs and EC2 and RDS. So I'm outputting two values. One is my web server public IP address and my RDS endpoint. So that is how a simplest template in CloudFormation looks like. So what I'm going to do is, let us say that we have written this and we need to validate it. I'm copying this, heading over to my console, and I have opened my CloudFormation dashboard. This is how it looks like if when you don't have any stack. And I want to create a new stack. So click on create new stack. And it is asking me, do I have the template saved, or do I want to use some pre-existing templates? No, I don't want to do any of that. I'm going to design my template. So click on that. And it is going to give me a nice another dashboard where I can update my code and write my code and edit it. So let me just increase the size. And here at the bottom, you will have components and templates. I'm talking about this section where you have components and templates. I'm going to click on templates. And the next thing that I'm going to do is choose the YAML format that is shown here. So once I choose this, the template looks, the brackets are all gone. I'm going to clear my screen and paste the code that we copied from the GitHub article. So the next thing that we need to do is I want you to look at here, because I'm going to validate my template. So for validating, I click on this option, which is a blue tick mark. That is this one, not blue, but anyway, that's a tick mark. If I do that, it says validating the template here, and then it says template is valid, and it disappears after that. So now that my template is valid, I'm not getting errors. Usually if you are getting an error, this is the area where you will be getting the error under messages. So you will go ahead and fix your errors. So assuming you don't have any errors, then the next step you need to do is go ahead, and I was supposed to do this. This is a button for clicking on creating the stack. Click on that, and it will copy your file to S3 bucket, and automatically it will take the S3 URL and update it here. You can see here my S3 bucket has been updated and the template URL is mentioned. So click on next. It is going to ask me the values, parameters, and everything now. So the first thing is asking me what is my stack. So I'm going to say this is Valaxy CF demo. That is my stack name, and CADR block. So remember the parameters I was grouping as a network section, EC2 instance configuration, RDS. This is how it looks like when it comes to the CloudFormation template itself. So it is asking me what is my CADR block. I am fine with this. So next question is, what is my public availability zone? So I'm just going to say my public is going to be in 1A and my private is going to be in 1B. And I'm going to leave the IP addresses in place because I know that they are the correct IP addresses and correct subnets has been split up. And what is my instance configuration? What is my instance name? I'm going to call my web instance as web server 01, or just put it this way, CF demo web server 01. And remember, we updated it, T2 micro, T2 nano, all of them should be visible now. See here, all of them are available here. Probably there is a typo in my template. Instead of nano, it says nana. So let us go ahead and choose micro itself. And environment, all of them are there. Let me just choose the default, and I'm going to leave all these defaults for all the other fields. And I'm just going to ensure that for Mumbai region, this instance, this AMA ID is the correct one. So if I go back to my template under mappings, I had the values So you see here for AP South, the value has to be CDB782. So I'm just going to change that for AP South. And I want a public instance. Yes, I want to true. And remember, I'm running in Mumbai region, so the default Virginia key is not taken into effect. If I click on this, it shows me the my Mumbai key, which is automatically picked up from my account. If I have multiple keys, you'd have listed all of them. Click on next. So it is asking me, do I want to have any tags? No, I don't want to add any tags, and I don't want any add IAM role. This role is for running the CloudFormation itself, not for running the resources. So I don't want any resources to be added. And when it comes to advanced, do I want to notify somebody? Yes, probably, but I don't have any topic as of now. You see here, all of them are listed empty. If I want to, I have to create a new SNS topic and subscribe to it. But as of now, I don't have any topics. So leave it as no. And termination protection. When something goes wrong, do you want to protect the resources that was created by this template? Do you want to enable it or not? So if you want to protect your resources, go ahead and choose it. Just like your EC2 termination protection, CloudFormation also has termination protection. And if you want that, click on enable. If not, click on disabled. How much time do you want to give this template to run? 10 minutes, 15 minutes? So just go ahead and say, let us say about 15 minutes. It should be coming up online before that. Do I want a rollback automatically when something goes wrong, as the message says, whether stack is rolled back? If creation fails, I'm going to leave it as yes, so that everything will be cleaned from my account. So click on next. It is going to verify everything, just all the things that we have chosen so far, and then click on create. So it is go back to your home page as if nothing has happened, but don't worry, click on the refresh button and you will see the stack creation in progress. So if I click on this and just do 1 second, yeah, you can see the events at the bottom. So if I go back and click on stack, it will show it on the same page itself. If I go back to events, it is going to list me all the events. As of now, we are here. Public route is created. You see here public route, and that was at 28. And I'm just going to hit on refresh. And the public route has become private route now. Just give it a moment. We should be able to get our resources up and online in a minute. You can see here my web server is already up and running and it should be ready for use. Probably 1 second, let me highlight my web server, the one that we are in particular interest. If I click on tags, it will show you that this web server was created by my Valaxy CF demo stack from the tags, and you can see here it has a public IP address and then a public domain name. I think this will work. Copy this and put it into my dashboard. You will see here, welcome to Valaxy CloudFormation demo. So that is what's supposed to see, and we are able to see that. Likewise, if I go to my database is getting created, and in a short while my database will also come online. Now that my stack is up and running, let us say that you want to make some changes to your stack. Quite often that is a request that users will be faced with. Let us say now in my security group, for my web security group, you can see here this is the web security group. There is a port 80 and port 22, and your manager comes back and says, I want port 443 also enabled, and I don't want port 22. What you are going to do is, all I'm going to do is go back to my template. Okay, not here. I mean to say, go back to my CloudFormation stack. This stack is getting still updated because it is still waiting for my RDS instance to come online, up and running. So once my RDS instance is up and running, it will allow me to make an edit. As you can see now, my stack is completed, and it has given me an update saying CloudFormation creation stack completion, because my RDS server is also complete. And if I go to my outputs section, you can see the RDS endpoint and then my EC2 server IP address or domain name is available here. So if I want to push some updates to my stack, I'm going to select my stack, click on actions, click on update stack, and it is asking me how do I want to update it. Do I have another URL or do I want to edit it in my template itself? Let us say I want to edit it in my template, and I'm going to update the ports so that port 22 will be removed and then port 443 will be added. So I can come here and then go to the correct section, which is public web security group. You can see here I am at a web security group. So all I'm going to do is I'm just going to copy this 4 lines, which is the rule for in these 4 lines. So I'm just going to say port 443 and input and output, that is from port and through port, and I'm going to remove these lines because I don't want to, my manager told me I don't want port 22 access to my web servers to my access. So I'm making this update, and then all I have to do is I'm going to validate my template once again. Let me validate it. If everything is good, we should be getting a good template is valid sign here, and then I'm going to click on create stack. So CloudFormation is going to recognize that this is an old template and allow me to change only certain values now. So if I go to the next field, you will see that. You can see here my stack name is not allowed to be changed, whereas I am allowed to do certain other fields, for example, my IP address or my subnets and all those kind of things. So let us make only push a small update, which is a port change. List of all the things my manager did not ask me to change. So I'm just going to click on next. And here I don't want to change anything. Once again, click on next. It is going to compare now what exactly has to change. So it is previewing my change, and it is trying to compute what are all the resources that needs to be modified. And it has done that comparison, and it says that the DB inbound rule, that is a security ingress, has been conditionally has to be changed, whereas the web security group also needs some modifications. So it has identified 2 modifications, and it is going to execute them when we are going to the next step. So click on update now, and let me refresh the screen, and you can see here there is an update in progress. And here you can see the update that is going to happen now for the web security group. So let me head over to my VPC dashboard, and you see here there are I have not refreshed my screen so far, so you can see here as of now my port 80 and the port 22 only are there. If I refresh my screen, this 22 should disappear and the 443 should appear there. So let's go ahead and do that. So there you go. You see here port 43 has appeared and port 80 has updated. 22 has been removed. So meanwhile, my CloudFormation should also has completed by now. So yeah, there we go. There is an update complete, and my CF is also been updated with my CloudFormation template being updated. So that is how you push a simple update and get your resources updated. So I did not touch my console at all. I just went and changed a few lines of code, and automatically my infrastructure is more secure now because I am allowing port 443 and removed 22 access. So that is how you push a simple update in CloudFormation. So in case if you don't want this environment, let us say you built it for test environment and you finished your testing and everything is done and complete. So you want to throw away an environment. Usually if you've done it manually, you need to clean up all the resources in the right order. Say for example, if you want to delete an EC2 and then you want to delete your VPCs and then you want to delete your subnets and all those things, it's a multiple clicks. But when it comes to CloudFormation, all you have to do is select your stack and click on actions and click on delete stack. So this way, all the resources that we have built in this demo are going to be deleted in sequential order, and you don't have to do any cleanup actions after this. So Amazon is going to take care of the cleanup completely here.